Okay, Assalamu alaikum students. Today we will study the new program, and that program is of Lagrange interpolation. So in the theory we have studied Lagrange polynomials, how to find out the Lagrange polynomials and how to apply this in the Lagrange interpolating polynomial P of x equals to L dot of x into y naught and that theorem. So only two steps, but we will start this how to figure out the Lagrange polynomials in MATLAB. So first of all you need is function. Write it as function, declare the function, and what you need is P of x polynomial. So I would say it P as an output and I would name it as Lagrange, and I have only two points or inputs x and y, or if you have function you can use the inline function. And one more thing is given, and that is x int means x interpolating point, interpolated point. X is equal to, it basically x is an array, and I would say the array is 1 space 3 space 4 space 6, and that's it. Similarly, y is an array. Y is also an array that is represented as -3 space 0 space 30 and space 132. So also x interpolated point is x int is equal to 5. These are the inputs, and now I have to declare the dimensions. How to find out the dimension of the Lagrange polynomials? N is equal to size of x comma 2. That represents that the interpolation is done between the 2 points, like x naught, x minus x naught. Differences are basically between 2 points, two columns basically, x minus x naught into x minus x1 into x minus x2. So only interpolation is between 2 points, so that is why it is you have to fix that dimensions. Column dimension is fixed to 2, fix x and y points. Okay, so this size will tell the dimension for this. And x means rows, means it depends how many x we have, how many points x we have. It makes the Lagrange polynomials according to that. If you have 4 points, then Lagrange polynomials should be of 4, Lagrange L1, L2, L3 and L4, but only between 2 points. 2 is fixed, column is fixed here, 2 is fixed. So this one, and the other one is let L is equal to initialization of Lagrange polynomials, and initialization is we have n dimensions comma 1, only one column, but n means how many Lagrange polynomials, how many points of x, it depends on how many points of x. So size command displays the dimensions of x, and n represents the dimension of that size command. So now we have only one column, and the one column and number of rows are depending upon the how many x we have, how much x we have, x1, x2, x3, x4. That means 4 cross 1 dimension. So once means it just initializes. For now we come to the constructing Lagrange polynomials. For I equals to 1 to n, and one more thing, for j equals to 1 to n. Allow if I is not equal to j, that condition not equal to j, then you can apply Lagrange polynomial here. L of I is equal to L of I multiply by, steric multiply means element wise, multiply by simple formula x int minus x of j. Every time it is updated, the previous Lagrange polynomial is multiplied and updated, divided by x of I minus x of j. So these will initially, for example, in the first place, if it is Lagrange polynomial is 1, and then depending upon the points and increasing, the Lagrange polynomials are increased depending upon how many Lagrange polynomials we have. And end, and now one more end for end. Okay, now let initialize the p is equal to 0. Okay, this multiplication is for the product summation. I would say you can use this as a product summation. For product summation you can use this technique, and also for that is why we have initialized it as once. And for some addition summation, you can initialize p is equal to 0, and you can use the theorem. You can use the theorem as p is equal to p plus, every time it is modified, y of I. For I equals to 1 to n, you have to use the loop. Y of I multiplied by Lagrange polynomial L of I. Last is for function end. So that is basically addition summation. Let it name be Lagrange. Yes, its answer is 75. And if you want to see the Lagrange polynomials, each and every step, you can remove here, and it will display the each and every Lagrange polynomial step by step. You can see like this. First one is 1 minus 1 1 1 1 1 1, and then it is modified as this, and then this, and then this, and final Lagrange polynomial is this. And then if you want to know the modified, every time modified value of p, then you can remove the semicolon here, but here it is 75. So this is all about the Lagrange interpolation. If you have any question, you can ask me in the online session. So thank you so much.